the Boeing Vertol Chinook, the Western world's standard medium-lift helicopter for almost 30 years. Immediately recognizable with its two rotors, one in front and one at the rear, the classic tandem arrangement. The world's first helicopter designed specifically for lift was also a tandem rotor design. The forefather of the Chinook, the Piasecki HRP was better known as the Flying Banana. The prototype first flew in 1947 in Philadelphia, the home of helicopter pioneer Frank Piasecki.
Philadelphia was sort of a center of rotary wing activity. And it was mainly because the Pitcairn family, Harold Pitcairn in particular, brought the Sierra patents from the British Sierra Company to the U.S. and set up a company in Willow Grove to manufacture autogyros.
For a young engineer, 1930s Philadelphia was an exciting town. Other rotorcraft manufacturers had followed Pitcairn's lead and set up factories there. Frank Piasecki took a ride in an autogyro and was hooked. He graduated in aeronautical engineering and went to work at the Platt-LePage Aircraft Corporation, manufacturers of the XR-1, America's first military helicopter. But Frank wasn't fulfilled by his job at Platt-LePage. With a group of young engineers, he built his own helicopter, the PV-2. By April 1943, the aircraft was ready to fly.
There were very few experienced pilots. There were about 7 people, Lou Levitt being one of amongst them, and he wasn't available. And so when we thought it over, including the prices, we decided it was me who was going to be the pilot.
As a pilot, Frank Piasecki only had 14 hours of fixed-wing flying time. He had to teach himself to fly the PV-2. Frank was the son of Polish immigrants. When the day of the first flight came, he used the only available open space, the local Polish picnic ground. In spite of some tricky moments, the first flights were encouraging enough to warrant the PV-2 being fitted with a complete skin. In its new streamlined form, it was rolled out for a continuing series of test flights. The PV-2, with its dynamically balanced rotor blades and full cyclic pitch control, was seen by Piasecki as a technology demonstrator. As the designer and the pilot, he was in a perfect position to get it right.
And it was a sweetheart. It could do anything. It was very controllable machine.
The PV-2 was only the second American helicopter to be demonstrated in public, but Frank Piasecki had another audience in mind. He showed the PV-2 to the Navy and tried to interest them in a large transport helicopter. He had some definite ideas about a new approach.
We said we would be absolutely honest to ourselves as to the estimates of weight and structural strength and all of the things required, so that we wouldn't come out with an absolute answer, but we would come out with a relative answer to each of the designs. And the tandem, no matter how we did it, no matter who did it, in this comparison and calculations, the tandem always came out better. And the reason for it became fairly obvious. One, all of your power is going into lift because the rotor, the counteracting the torque, was automatic by the fact that the two rotors turn in opposite directions. So that was fundamental.
But the Navy wasn't interested, and Piasecki took the idea to the Coast Guard. On New Year's Day 1944, he signed a contract with the Coast Guard to build an experimental helicopter. The first Piasecki tandem helicopter had the designation XH-RPX, but to the Piasecki Company, it was known as the Dog Ship. The rotors of the Dog Ship had a diameter of 41 feet, and the fuselage was 48 feet long. It was designed to cruise at almost 100 miles an hour and to carry a load that was unheard of for helicopters.
So our effective useful load of 1,900 pounds in those days was roughly 3 times the size of anything that was flying at that time.
At the time, the Dogship was the world's largest helicopter. It could carry 2 crew and 10 passengers. It was powered by one Continental R975 engine, developing 450 horsepower. That engine drove both sets of rotors. Weight was crucial, and when the Dogship finally got a skin, it was made from the lightest available material, balloon cloth. The Dogship was not a prototype. It was seen as a flying mock-up. This way it was possible to measure its flight and control characteristics, with a view to improving them when the prototype was built. The Dogship could also be used for demonstration to prospective buyers. The Navy was now convinced, and it ordered 2 prototypes, designated HRP-1, for further testing. They had Pratt & Whitney R1340 radial engines of 600 horsepower. Like the Dogship, the prototype HRP-1s flew without a skin, and their performance was impressive enough for the Navy to place an order in June 1946 for 10 production models. Later, they ordered another 10. When the HRP-1 went into service in June 1947, the bent fuselage shape immediately created interest. From then on, it was stuck with the name Flying Banana.
People didn't realize why that shape was, but it was because you had to have clearance in the middle of the fuselage for the rotor blade flapping. And of course, as you flew forward and you tilted the machine, the front part of the machine was level, and the rear part was up as a rear pylon.
In 1945, the U.S. Navy issued requirements for a compact utility and rescue helicopter to operate at sea. This Piasecki design, the HUP-1, made its first flight in October 1948. It won the naval competition against a Sikorsky single-rotor design and went into service in 1949. The overlapping rotors gave it an advantage in the cramped space of small aircraft carriers.
This made it possible for the design to be brought up into the carrier elevator, the rear rotor unlocked and phased properly so that its blades were in the proper corners and the front rotor in the proper corners, and then dropped immediately without any folding of the blades, which made a tremendous time advantage to the overlap tandem.
But the overlapping rotors produced more downwash than single-rotor helicopters,
because the downwash of one rotor added to the downwash of the other. So you had a bigger downwash in the center, but we had enough blade area and enough power, and we were so much more efficient than the single rotor that didn't really bother us.
339 Piasecki HUP helicopters were built, and they gave 20 years of service to military forces in the U.S., Canada, and France. The HRP-2 was an improved version of the original HRP-1 Flying Banana. The pilot now sat forward of the front rotor, and the helicopter was given a metal skin. Its successor, the H-21 Workhorse, was designed at the height of the Cold War as a high-altitude rescue helicopter, able to pick up returning bomber crews if they went down in the mountains of Alaska. It was a challenge to any new pilot.
We found that when the pilot made a hovering turn, he made it about himself. And he became the center of the turn, and the rest of the machine went all around him. You could, if you forced yourself as a pilot, rotate the machine exactly on its center of gravity. But that meant that you were flying sideways with the tip of the machine, with the end of the machine, and so you were going laterally and around in a circle yourself, which wasn't exactly what a pilot likes to do.
The workhorse was given a larger engine and rotor system to cope with the possibility of rescues at high altitude. Two massive drive shafts connected the 1,425 horsepower engine to the front and rear rotors. The rotor diameter was now 44 feet, and drive shaft maintenance was crucial to the safety of these large tandem helicopters. The H-21 lived up to its name. It was a real workhorse, able to operate in a variety of configurations and perform many different jobs. In 1955, the H-21 was adapted for testing in quite a new role.
And because of its size and weight and capacity of about 13,000 pounds gross weight, it was used as the test bed to mount the machine guns down at Fort Rucker. And I was there when they were mounting a 50 caliber machine gun on the front landing gear because it was expeditious to do that.
This H-21 bristled with guns in almost every possible location. The workhorse became the first helicopter to go into service with 50 caliber machine guns when the French used them as gun platforms in Algeria. But its major war service took place in Vietnam in the early years of American non-combat support to the South Vietnamese Army from 1961 to 1963. When the Piasecki H-16 made its first flight on October 23, 1953, it was the largest helicopter in the world. Its rotor diameter was 82 feet, almost twice that of the H-21 workhorse. Powering this monster was a design challenge.
It was originally with two piston engines, one at each end of the aircraft, in their own engine rooms. It was quite interesting how everybody was enhanced by the fact that here was a helicopter that had an engine room.
The huge overlapping rotors were made of aluminum skin with a honeycomb composite filling. The H-16's fuselage had the capacity of a four-engined airliner and could lift up to 14,000 pounds.
We later on, in the second model, went to turbines, and we had two turbines driving the machine. It was very successful. It had 82-foot diameter rotors, but the RPM was so slow that any vibratory motion from the rotors, which were three-bladed, would come in almost as a loping action. And you could actually almost see the rotor blades turning. You could actually watch the blade as it turned around.
The turbine engines chosen for the YH-16A were Allison T-38 turboshafts, each delivering 1,800 horsepower. The helicopter in this turbine-powered form first flew in 1955. In this form, the YH-16A was known as the Turbo Transporter. In 1955, Frank Piasecki left the company. It was renamed Vertol. Piasecki formed a new company, the Piasecki Aircraft Corporation. In early 1956, the YH-16A set an unofficial world speed record of 166 miles an hour. But shortly after, a test equipment failure caused it to crash, and hopes for a promising future were destroyed. This is the Bristol 192 Belvedere, a turbine-powered tandem-rotor helicopter from England. The original piston-engine model was designed in the late 1940s using Frank Piasecki's concepts. The prototype made its first flight in 1952. Civilian airline trials were conducted in 1956, but no commercial orders were received. Because of an accident, the civilian test version was taken out of service. The turbine-powered 192 made its first flight on July 5, 1958. 26 were produced for the British Royal Air Force. They went into service in late 1961. They were used briefly in service in Southeast Asia during the Indonesian confrontation crisis in the early 1960s. The Belvedere had two Rolls-Royce Napier Gazelle turbine engines of 1,650 horsepower. The rotors had a diameter of 48 feet. The Belvedere could carry 19 fully equipped troops or lift 6,000 pounds of cargo, either packed internally or slung underneath. Its maximum speed was 138 miles an hour, and it had a range of 437 miles. The Belvedere remained in service with the Air Force until 1969. Meanwhile, in America, Frank Piasecki, the man who originated the tandem rotor concept, was turning his attention to other forms of rotorcraft.
Well, we did not want to be in competition with our own designs, and so we said, okay, let's not do anything with a tandem because that's been fairly well established, and so let's not fight against ourselves.
Having left the big tandem helicopter behind, Piasecki turned his attention to exploring designs for radical forms of rotorcraft. This is the prototype of the Flying Jeep Skycar, or Air Jeep. It was the winner of an Army competition for a vehicle that was invisible to radar because of its ability to follow the contours of the Earth and remain under the radar signal. It made its first flight in September 1958, with Frank Piasecki at the controls. Lift, propulsion, and control all came from the ducted rotors. The pitch of each one could be changed independently, so the front or the rear could be lifted. A combination of cyclic pitch and vanes on the rotors gave directional control. The test program examined its potential as a stealthy weapons-carrying system.
The Jeep was designed to fly under the trees, just feet off the ground, and under the foliage.
The next stage was a turbine-powered version, with the rotors mounted on an angle. But the project was shelved in the early 60s. By 1960, Piasecki's old company had been taken over by Boeing and became Boeing Vertol. It was heavily involved in the development of a new medium-lift tandem helicopter for the United States Army. That helicopter was designated CH-47, but it would become known worldwide as the Chinook. It couldn't have come at a better time. America was already involved in Vietnam, and the Piasecki H-21 stationed there were showing their age. When the Chinook arrived in Vietnam in 1965, it had a huge and immediate impact. (1962). At the Piasecki Aircraft Corporation, another of Frank Piasecki's innovative ideas was being tested. He'd been working on the design of a ducted fan, which could be fitted to the rear of a small single-rotor helicopter. The idea was to increase its speed in level flight. Testbed was the 16H-1 Pathfinder, Piasecki's first single main-rotor helicopter since the early PV-2. The fan system wasn't only used for forward speed. The helicopter's foot pedals operated vanes in the ringtail, as the fan was called, to counteract torque and give directional control. The next test bed was the 16H-1A Pathfinder II. Modifications had been sponsored by the Army and Navy. and its goal was speeds up to 230 miles an hour. It was a compound helicopter with a small wing to take the load off the rotor in forward flight. In tests, it showed off its extreme maneuverability. The Pathfinder II almost succeeded in reaching its speed target in level flight. It flew at 225 miles an hour. While the Pathfinder never went into production, the idea of the ringtail ducted fan system is still well and truly alive. Frank Piasecki has been involved with helicopters for more than 50 years. His legacy of innovation has a continuing effect on the helicopter industry.
The Sikorsky Blackhawk has been a reliable warhorse for the U.S. Armed Forces. For over 35 years, it has been leading the charge into hostile territory, from the deserts of Iraq to the mountains of Afghanistan. The rhythmic pulse of its blades are both a signal to wounded American men and women that help is on the way, and a warning to enemy forces that trouble is on the horizon. After decades of upgrades, they remain some of the most sophisticated aircraft in the world. But is it possible to create an even more advanced machine using today's technology? What if the world's rotorcraft manufacturers started with a blank sheet and reimagined the helicopter from the ground up? In some ways, Vietnam was a helicopter war. Helicopters were key to moving troops and equipment in and out of hostile territory and airlifting the wounded to safety. They also fearlessly charged into battle, serving as spotters or leading the assaults themselves. The Bell UH-1 Huey was a vital member of America's stable of helicopters. Though designed as a transport, it would be pressed into many roles under the pressures of war, from rescue craft to flying gunship. Though it was a noble warrior, even with continuous upgrades, it was still largely based on technology from the 1950s, and by the late 60s, the U.S. Army was looking for an upgrade. Their quest for a replacement would lead to the birth of the Black Hawk.
The Black Hawk started out as a replacement for the Bell UH-1 Huey, which was widely used in the Vietnam War, in fact became iconic of the Vietnam War. And they took all that experience they had learned in the Vietnam War and they applied it to the requirement for what was then called the UTTAS or UTAS, which was Utility Tactical Transport Aviation System in the early 70s.
3 of today's leading rotorcraft manufacturers took up the UTTAS challenge, designing the heir apparent to the Huey: Bell Helicopter, Boeing Vertol, and Sikorsky. After evaluating the proposals, Boeing and Sikorsky were given the go-ahead to construct prototypes. An intense competition between the two designs followed, with the Sikorsky Blackhawk ultimately winning the crown from the Huey. It wasn't long before the Blackhawk was building its own name as a legendary rotorcraft.
Really what made the Black Hawk the helicopter it is they took all that experience they'd learned in the Vietnam War about survivability, about crashworthiness, about the ability to carry a complete team of soldiers, not have to have several helicopters to carry them. And that really made the Black Hawk the utility machine it became.
The Black Hawk design has proven to be so robust that it's been adapted for the Navy as a Seahawk. It's also used around the world with many different countries. It's one of the most ubiquitous helicopter designs of the 20th century.
Extensive modifications have kept the Black Hawk at the forefront of technology, but it is still based on a 40-year-old design. As tough a warrior as the Black Hawk has been, after participating in 2 desert wars, there were questions about its suitability in future air battles. Has the Black Hawk finally reached the end of the line?
Even though they've gone from the UH-60L to the UH-60M and they've got bigger engines and a bigger rotor, they now find themselves operating in high temperatures and high altitudes, and they realize they don't have the performance they thought they had. Not only that, but they're being shot at again, and they're crashing in sand and other problems. So they really come back from Iraq and Afghanistan realizing that the helicopter that's done them well for the last few decades is not going to do them well for the next few decades. So they start to lay out their plans for a replacement and to take all that experience they've learned from fighting in the desert and fighting in the mountains and apply it to a new helicopter that they think will be more suited to a future war that is not on a flat, grassy, green battlefield somewhere, but is going to be, they don't know where. And that's the point. They want a helicopter that will fight wherever they end up fighting.
The U.S. Army's FVL, or Future Vertical Lift program, was conceived to explore replacements for not only the Black Hawk, but for the rest of its aging stable of rotorcraft. The new breed of rotorcraft will not only use the latest breakthroughs in technology, they will also share common parts, making building and maintaining the fleet a more economical process. JMR, or the Joint Multi-Role Helicopter Program, is a competition to evaluate the technologies that will go into FVL helicopters.
So JMR is being led by the Army, but it's developing technologies in concert with the other services for the Future Vertical Lift program. In the competition, both Bell and Karem aircraft were looking at tilt rotors, and AVX and Sikorsky Boeing were looking at a compound helicopter. Now, each company had a very different take on these approaches, but the key was high speed and long range.
The goal they've set is 230 knots. 230 knots is somewhere between 50 and 100% faster than a Black Hawk. A Black Hawk can do 170 knots. It never does 170 knots. The most it'll do is 150 knots. In hot and high, it'll only do 110 knots. So when you talk about 230 knots, you're talking about, in effect, twice as fast as the Black Hawk. And then you're talking about adding the range so they can go twice as far, twice as fast. So that's sort of like a threshold the Army said we want to look at. We want you, industry, to show us, the customer, that we can afford to go twice as fast, twice as far. That's what Joint Multi-Role is all about. It does not mean that the Black Hawk replacement will fly twice as far, twice as fast as a Black Hawk, because the Army might still decide it can't afford to go twice as far, twice as fast.
The JMR competition saw two relative newcomers in the rotorcraft world take up the Army's challenge to go twice as far and fast. The AVX Aircraft Company and Karem Aircraft, a company founded by Abraham Karem, the father of the Predator drone.
So AVX and Karem both had really interesting approaches to this mission requirement. AVX was looking at more of a lower cost version of a high-speed compound, where Karem was looking at a really advanced tilt rotor, which they believed could hit much higher speeds and much longer range with what they call their optimal speed tilt rotor, OSTR.
Bell Helicopter, manufacturer of the V-22 Osprey, put forth a similar-looking rotorcraft for JMR. A byproduct of its tilt rotor design is phenomenal power.
The Bell helicopter design, it's actually a 280 knot machine, which is much faster than the Army says it needs. But that speed actually falls out of the amount of power that it needs to take off and land vertically. So they put these two 5,000 shaft horsepower class engines on it to be able to take off and land vertically at the sort of 30,000 pound gross weight that the Army thinks this thing is going to weigh, which is about 10,000 pounds more than a Black Hawk. And then once you put those rotors down into cruise mode and it becomes a turboprop, you've got the power on board to go 280 knots, maybe even faster. So Bell uses that as an advantage when it does all of its tactical calculations about how many V-280s do you need to cover an area of responsibility, a battlefield. They've got this enormous speed advantage, and speed equals range in this case. Is how far can you go in a set amount of time. So to them, they use speed as an advantage.
The team of Sikorsky Boeing have a head start in their Defiant, conceived for JMR, having created 2 advanced compound helicopter prototypes with their own funds.
Sikorsky Bell, they've demonstrated with the X2 technology demonstrator that they can go to about 260 knots with this coaxial rotor, rigid coaxial rotor design. The Raider, which is the slightly bigger prototype they're building, they're aiming for about 240 knots. They think it'll go faster than that, but they're aiming for about 240 knots, clean, with the weapons tucked away. 220 knots if they have the weapon doors open and the weapons deployed. JMR, they're saying 230 knots. They think it will probably go as fast as 270 knots when it's clean. These are fast machines.
The Army narrowed the field of competitors from 4 to 2. It's not that surprising that Bell Helicopter and Sikorsky Boeing were the last 2 left standing. Though all teams had something unique to offer, the Army may have chosen to make a safer bet by siding with the larger companies with a longer proven track record. The great difference in their approaches allow the Army to evaluate 2 completely different systems.
The approach from Bell is a tilt rotor. The tilt rotor tends to be inherently better at cruise and more efficient for loiter because it has a wing. It can use wing-borne flight. It can use aerodynamics to keep the aircraft aloft rather than the helicopter's rotor pushing down. A compound helicopter, which it basically takes a helicopter and puts a pusher propeller on it to make it go faster, and it can also go farther because it's not using the helicopter rotor to do both lift and forward thrust. And that's what Sikorsky and Boeing are looking at.
The origins of Sikorsky Boeing's choice of design go back to the early 2000s, when Sikorsky was working on its own. The success of the Black Hawk enabled them to take helicopter technology in new directions.
Sikorsky was making a lot of money on building Black Hawks by the 100 for the Army. And they basically decided to start putting some of that profit into demonstrating technology for what they thought the next generation of rotorcraft would be. Now, they went off and they looked at all the possibilities. They looked at tilt rotor. They looked at variable diameter tilt rotor. They looked at other possibilities, and they came down on a design they'd actually done before.
In the early 70s, Sikorsky developed the XH-59. This was an experimental machine designed to test the advanced blade concept that is using 2 rigid contra-rotating rotors. Russian manufacturer Karmov had already produced several successful coaxial rotor designs. The concept had great potential, but it had a fatal flaw.
It's a very efficient hovering machine. If you think about it, the rotors get 2 chances to bite at the air. First rotor pulls the air through, gets some lift, pushes its second rotor, pulls the air through, gets some more lift. Very efficient hovering machine, but slow because you're pushing 2 rotors through the air when you're going forward. So back in the late 60s, Sikorsky with Army and NASA set out to design a high-speed helicopter and demonstrate they could fly fast with this thing called the XH-59. So the XH-59 had coaxial rotors, but they were very close together. They were very stiff, so they wouldn't bump into each other, but that allowed them to put them only inches apart, which dramatically reduced the drag of the rotor system when they pushed it forward, because the rotors were close together. There wasn't a long, thin mast between the rotors. If you look at a Kamov design, several feet between the rotors. You push that forward, it generates a lot of drag. So they did this, they flew this, they did something around 260, 270 knots. But it was very complicated. It took 2 pilots to fly this helicopter, and it had 4 engines. It had 2 engines driving the rotors and 2 jet engines pushing it forward. So basically they decided that's not a good idea, and that went back on the shelf.
Though the XH-59 was overly complicated, might advances in technology make the basic concept the foundation for a new generation of helicopters?
In the early 2000s, there's Sikorsky saying, what's the next generation of rotorcraft? And they looked at all of the technology we've developed since. They looked at fly-by-wire. They looked at composites. They looked at integrated flight and propulsion control. They looked at vibration suppression, active vibration control. And they said, we can do that. We can do what we did with the XH-59, but we can do it with one engine, one pilot, and less vibration at twice the speed of a Black Hawk. So they set out to demonstrate with a thing called the X2 technology demonstrator.
So this uses a very closely spaced coaxial rotor, counter-rotating rotor, and then a pusher propeller. And they've proved with their X2 demonstrator that they could reach speeds of about 250 knots.
Very successful, done as a sort of a rapid prototype in a sort of skunk works type operation. Small team, put it together, flew it. Having shown that, they then decided to put more of their money where their mouth was, and they decided to put $200 million of industry money into building 2 prototypes of a light tactical helicopter called the S-97 Raider.
The X2 and S-97 Raider were not developed specifically for the JMR competition. Originally, Sikorsky hoped to replace an aging scout helicopter, the Bell OH-58 Kiowa.
The S-97 currently is not part of the future vertical lift family of aircraft. It's a company-funded demonstrator that they would like to have purchased by the Army and other services as a light attack helicopter. The Army has had an outstanding requirement for decades now to develop a new attack scout helicopter. It was going to be Comanche, but then after billions of dollars and a couple decades of development, they ended up having to cancel that program.
Sikorsky hoped by building and flying the X2 and S-97 Raider, the Army couldn't help but purchase their design for a new high-speed scout helicopter. It was a gamble that didn't work out as Sikorsky had planned.
Well, it went a bit awry. The Army sort of lost direction, really. And then eventually, when the budgets got tight, the Army decided it couldn't afford an armed scout helicopter. But Sikorsky just kept going, and it will build and it will fly the S-97, and they'll demonstrate it to the Army. And they're hoping that, when budgets ease off and the Army realizes that it really does need a scout helicopter, they'll be there and ready when they come back. And there may be other requirements. The special operations folks have still got to replace their Little Bird helicopters, so they think there's something out there that eventually they may come. Meanwhile, the S-97 Raider is a good stepping stone towards joint multi-role and future vertical lift. It's significantly bigger than the original technology demonstrator, but it's significantly smaller than the joint multi-role. So joint multi-role takes that next step in size.
Sikorsky has a larger version of the S-97 in development, especially for the JMR contest, known as the Defied. This is a medium-sized helicopter and a Black Hawk replacement. JMR will ultimately call for 4 sizes of helicopter to be produced to replace 25 helicopters currently in operation. Sikorsky's proven ability to scale its compound design could be a key advantage.
If you're in the rotorcraft, the biggest risk you face in designing a helicopter is scaling. Something works at one size, you then go and make it another size, and all of a sudden a whole bunch of problems turn up that you didn't realize. So if you're going to convince the Army that high speed is doable and affordable, you've got to get rid of all the areas of risk that you can. So scaling this up from the X2 technology demonstrator to the S-97 Raider and now to the JMR TD allows Sikorsky to remove the risk of scaling.
Sikorsky boosted its odds of success by partnering with another giant in aviation and one of its great rivals.
Along the way, Sikorsky surprised us all by teaming with Boeing for this. Up till then, everybody had expected that Boeing would bid on its own. Not because they really had any incumbency on the Black Hawk. That was Sikorsky's business to win or lose. But because the Army was saying that eventually either the actual vehicle or certainly the technology that was in the Black Hawk replacement would be the basis for the Apache replacement. So Boeing was looking, saying, we're the incumbent on Apache, we've got to protect our turf, we've got to be in on JMR and FVL, because if we're not, and then the Army does decide to take the dynamic system or the entire airframe and repurpose it for the attack mission, we'll be out of the running. So Boeing was doing its own work, and Boeing actually was heading towards a tandem rotor design, because if you look at Boeing, they do a lot, Chinook, very successful. And the mission for the Black Hawk replacement drove Boeing to a tandem rotor. Was never going to get, that was not going to work, that was not going to be competitive. So eventually they decided to team. So now you have the company that's the incumbent on the Black Hawk and the company that's the incumbent on the Apache, which make up 60% of the Army's helicopter fleet, tied together on the potential replacement for all of those helicopters. They stayed with Sikorsky's X2 configuration, but Boeing brings in its composite airframe technology, its integrated avionics technology, and other things like that to help Sikorsky make this design as competitive as they can.
Though Sikorsky and Boeing made a formidable team, they faced stiff opposition from legendary rotorcraft manufacturer Bell. Bell's V-280 Valor builds on many of the lessons learned from years of research in tilt-rotor design.
Bell is describing the V-280 Valor as what they call a third-generation tilt-rotor, which makes you go, what are the other two generations? Second generation clearly is the V-22 Osprey. The first generation is the XV-15, the original experimental tilt-rotor that flew back in the 1970s, I think. That was an extremely successful aircraft.
The XV-15 proved the potential of the tilt-rotor system. However, when creating the Osprey, designers had a tough challenge meeting the rigid set of new requirements set by the Marines.
One of the challenges with the V-22 Osprey is it had to fit on the Marine Corps' assault ships, and we have a taxi past the island. So that made the wingspan much shorter than it would have liked to have been. Then also having to rotate the wings and fold the blades, make it very compact for storage under the deck, made it more complicated.
So the V-22 ended up having the rotors are too small, the wings too small. It works, but it's a highly compromised tilt rotor. So when we come to the V-280, basically Bell goes back to the original intent of the tilt rotor and has an uncompromised design. Because this thing doesn't have to fold, it doesn't have to go on a deck, it doesn't have to go under a deck, they can make the rotor diameter what it should be, they can make the wingspan what it should be, they can take the forward sweep off that they put on the V-22, they can remove that and have a straight wing which is lighter. And then there's all sorts of other things they had to put into the V-22 so it could operate in a maritime environment that they just can remove. They don't need it for an Army helicopter.
Although Bell had a much freer hand in designing the V-280, there were still many nagging concerns about its tilt-rotor design, the foremost being cost.
Bell, as it builds the Joint Multi-Role demonstrator, is really trying to prove one major point. And that major point is they can build a tilt rotor for the price of a conventional helicopter. If they can't prove they can build this aircraft at a reasonable price, they're dead in the water.
Bell's Osprey has become a vital part of U.S. Marine operations. Its success is strong evidence of the utility and versatility of the tilt rotor. But the V-280 Valor is being constructed for the Army and for a different type of mission altogether.
One of the big things I think Bell has to prove is whether or not a tilt rotor can actually do the mission that the Black Hawk does, which is flying into a firefight to drop off troops, pick up the wounded. You're not talking about the way the V-22 is necessarily operated, which is much more of a transport role.
The V-22 has really proven itself in the conflicts in Afghanistan and around the world with its ability to get in someplace long range, get there fast, hover, land, and get out. So it's really proven itself over the last 7 years it's been in operation.
The tactics that the Marines have evolved with the V-22 to make it survivable is that it stays fast for as long as it can. It basically flies in fast with the rotors down in turboprop mode, and then at the last minute they swing the rotors up into helicopter mode, they land, they load, unload, they take off, they put the turboprops down as quick as they can, and they accelerate out of the danger zone. Their exposure is very limited. That's how they've sort of got around the vulnerability that comes with the complexity of the tilt rotor. Bell has got to prove whether that applies to the Black Hawk mission. If it's going to be hovering more than the V-22 is, it's going to be exposed to fire more.
Ensuring the safety and survival of the crew to and from the target is a key part of any rotorcraft mission dossier. A byproduct of the V-280's tilt-rotor design is an easy escape route.
Because they tilt only the rotors and not the engines, if you think about it, the V-22, they tilt the entire nacelle, so the hot exhaust comes close to the ground when they're in hover mode. In the V-280, they only tilt the rotor, and the engines stay fixed on the ends of the wing. One reason is simplicity. The second reason is so that they can unload the troops from the side doors, and they can run sideways away from the aircraft, which is what they do with the Black Hawk. Whereas in the V-22, they can only go out the back door. Now, out the back door is fine, but you can't exit the aircraft as fast. You can't empty the aircraft or load his aircraft as fast if all of your troops have to go out the back door.
The V-280's side doors provide a faster means of escape than those of the V-22, but both aircraft are enticing targets for enemy fire.
It's hard to say whether a tilt rotor is more vulnerable than a conventional helicopter. It still has engines, gearboxes, rotors, all of which are things that can be shot at. It's really more a case of it's a physically larger signature to shoot at. And it's really this, can they minimize the amount of time that it's on the ground? And can they harden it? I mean, can they make sure that the rotor system can take a shot? On the V-22, they're able to minimize the exposure by the way they operate it. Where the Army may operate a tilt rotor would be very different. So it's going to be a different calculation, and that's going to be a key part of the demonstration.
The Army has a difficult decision to make, choosing between excellent proposals from Bell and Sikorsky Boeing. They are hopeful that this new rotorcraft will be instilled with one quality absent from the Black Hawk: self-sufficiency.
The Army wants whatever it buys to replace the Black Hawk, it wants it to be able to self-deploy. At the moment, if you go abroad with a Black Hawk, you either have to hop from island to island, in effect, to get somewhere, or you have to pack them up, put them in a C-5 Galaxy or a C-17 and fly them. And that takes an enormous amount of strategic airlift to move all of the Black Hawks needed to support an Army division or something like that. The goal the Army has set is they want to go 2,100 miles, which is the longest leg anywhere in the world. It's Hawaii to Los Angeles, I think. No refueling, all the fuel in extra tanks on board the helicopter. So basically, when an Army division deploys, the helicopters will go out on their own and will be waiting when they arrive. That simplifies it for the aircraft designers. They've got to put the fuel in there, but it means you don't have to fold this thing up to go inside an aircraft. You don't have to take the rotors off, make it fit. For Bell, that's a big advantage because that removes one of the big problems of the V-22 is the weight of all that folding mechanism is a huge weight for the V-22 and makes it very, very relatively inefficient for a tilt rotor. With the V-280, they can bolt the wing onto the fuselage. They can go for a very simple structure. It's all composite. The V-22 is composite, but it's what people call black aluminium. If you go in a V-22 and you look at the structure, it looks like it's aluminium. It has fasteners, it has frames, it has stringers, it has all things you'd expect in an aluminium structure, but it's actually carbon fiber. If you go into a V-280, they've gone to the what you can do with composites. Big self-supporting structures, some major frames, but not lots of frames, not lots of stringers. It's basically honeycomb stiffened structure for the wing and the fuselage, which is very light and very simple to produce.
The JMR competition is more of a marathon. Sikorsky, Boeing, and Bell are building rotorcraft to test and demonstrate technology only. The actual competition to build the Black Hawk replacement is to follow.
Everybody involved gets a second chance. Not only that, but on the current plans, the Army intends in the FVLM program to fund 2 competing Y-plane prototypes. So we could have a situation where Bell and Sikorsky Boeing fly their demonstrators in 2017, go into another competition, and then fly Y-plane aircraft in 2025. and then down select to the aircraft that would be finally developed to replace the Black Hawk. So we're a long way from knowing who's won here. And it's important to remember that the Army has this second chance to choose, and also the Army has yet to decide it wants a fast helicopter. After all this, it could decide it wants a conventional helicopter because it's cheaper. After all this, the Army could decide to upgrade the Black Hawk again. It's done it from the A to the L and from the L to the M. There could be another generation of Black Hawk to come along. They're already planning to put a bigger engine in the Black Hawk, the ITEP engine. Sikorsky also has technology available to put an active rotor on the Black Hawk. I don't know whether in some dark room they've got some way of putting a coaxial rotor on a Black Hawk. We don't know. All we know is it's likely that the Army will upgrade the Black Hawk again, and it's possible they may go for a conventional helicopter to replace their fuel. They may not go for either of the fast rotorcraft.
With the Black Hawk replacement 20 years away, one has to question if the Army's timeline makes sense, and whether the technology developed in that time frame will be worth the wait.
2035 is a very long time from now, but some of that is we want to get this right. This is the first new development aircraft for the Army and most of the other services since the 1970s. So we want to see what is possible with the current state of the art, what we can prove, what would be possible for the next generation of aircraft.
Both Bell and Sikorsky Boeing have excellent designs and proven track records constructing rotorcraft for the U.S. Armed Forces. But who holds the edge in the competition? Perhaps Sikorsky Boeing's biggest advantage isn't technical. It's that they have the most to lose.
As we stand today, and you look at how the teams are lined up, we've got Bell on one side, we've got Sikorsky and Boeing on the other, and then we have the other two players, the small guys who got cut out this time round, the AVX aircraft and Karam aircraft, who may yet attract some bigger backers for the next stage. You have to say to yourself that it's Sikorsky and Boeing's competition to lose. They are the incumbents on the UH-60 Black Hawk utility helicopter and the H-64 Apache attack helicopter. It's their business to lose. But it's also a huge market. We're talking 3,000 helicopters plus all of the export, thousands of helicopters that export customers buy. Nobody's going to let them just walk in and take that. They're going to have to prove they can do it. They have a good technology base. They've flown the X2 technology demonstrator. They're building the S-97 radar. That configuration with the rigid coaxial rotors and the pusher propeller on the back is going to be well proven by the time they fly their demonstrator.
On May 22, 2015, a test took place critical to the future of Sikorsky Boeing's compound helicopter design. On that day, the S-97 Raider was to lift off for the very first time. Scientists and engineers gathered at the Sikorsky Development Flight Center in West Palm Beach, Florida, to scrutinize the event. They watched anxiously as pilots Bill Fell and Kevin Bredenbeck gingerly took the Raider into the air.
All right, just a few words here. So another first and a proud heritage of first for Sikorsky aircraft is now in the history books. A special thanks goes out to the entire Raider team, Kevin and I, for building this phenomenal machine.
A month after Sikorsky's triumph, it was announced that defense manufacturing giant Lockheed Martin was purchasing the company for $9 billion, perhaps bolstering its hand even more in the helicopter competition. Still, even with the success of the Raider and the added support of Lockheed Martin, victory is not a foregone conclusion. Sikorsky Boeing still have much to prove to win the next phase of the competition, as do their main rivals, Bell.
Bell has a higher hill to climb. They can offer very high performance with the tilt rotor, but they have got to prove they can build that rotorcraft at an affordable price. They've also got to prove that it can do the Black Hawk mission. The V-22 does not spend a lot of time hovering. Black Hawk spends most of its time hanging around, hovering. And so the other thing that Bell's got to prove is they can hang around and hover as efficiently as a rotorcraft. Sikorsky and Boeing don't have that problem. They know that they can hang around and hover efficiently. A coaxial rotor is a very efficient hovering machine. They've got to prove that that whole combination, the complexity of having two main rotors and a propeller on the back and integrating all that propulsion with flight control, they've got to prove to the Army that that's worthwhile. So they've got to prove that it's affordable. They've also got to prove there's some interesting ways you can fly the helicopter when you've got that propeller hanging out the back. You can do flat attitude approaches. You can hang on it, point the helicopter. They've got to prove that that means something in the utility mission. It's not just nice to have, but you can actually do some real things. So they've got some things to prove as well. But as we stand today, you've got to look at what Sikorsky and Boeing have to lose and think that they are going to put everything into winning this. Bell, it's not as existential for Bell. It's not business they now have. If they lose this, they don't lose business they already have. If they win this, they win a market they don't have. But there is no doubt that for the US rotorcraft industry, this competition for FVL, Future Vertical Lift, is the one that's going to decide who dominates the industry for the next 50 years.
It will be a long time before the shape of the next generation of rotorcraft becomes clear. Much time and money is being invested by Sikorsky Boeing and Bell to create new, faster helicopters. But the Army still might choose to go with a slower, cheaper design. Still, the knowledge gained constructing these awesome machines might still be applied to more conventional rotorcraft. As well, Param Aircraft or AVX could make a return to the main stage and strike back with a contract-winning design of their own. All that we can be certain of is that the Black Hawk will soldier on until a new helicopter finally materializes, worthy to relieve it from duty.
He was a Russian by birth. He fled the motherland one step ahead of a Bolshevik firing squad. He designed and built the first four-engine airplane, the first airplane with an enclosed cockpit, and together with Charles Lindbergh, cooked up the seaplanes that made international airlines practical. Lindbergh called him the greatest aviation engineer he'd ever met.
He showed tremendous scientific talent at a very early age. By the time he was 11 or 12, he had read how to build small electrical motors, but he couldn't find any in Kiev at that time, so we actually began to take the bobbins from his mother's sewing machine and wrap them with wire, and he created his own electrical motors that he then powered with batteries by taking pickle jars and making batteries out of them.
For all his fixed-wing achievements, however, he is most closely identified with helicopters. For it was the helicopter company he founded relatively late in his life that turned his name into a household word. He is Igor Sikorsky, and he is a legend of air power. Igor Ivanovich Sikorsky was born May 25, 1889 in Kiev, Russia. His father was a psychology professor and his mother a doctor, and together they nurtured their son's early interest in science.
His life was in a home in which he was felt very sheltered, very secure, very happy, in a home in which his father encouraged scientific research and encouraged daydreaming. He read what today we call science fiction books, primarily Jules Verne. He loved Jules Verne, 20,000 Leagues Under the Sea, 80 Days Around the World, A Voyage to the Moon. But primarily, there was one book, Robur the Conqueror, also known as, prophetically, The Clipper of the Clouds. And it's very, not too well known here in America, but it's a book that describes a flying machine very accurately, actually a helicopter. Very, very accurately describes a helicopter some, obviously, 40, 50 years before it was ever flown.
He attended the Petrograd Naval College, but left in 1906 to study engineering in Paris, then the center of aviation in Europe. His time in France was a revelation. The Wright brothers were demonstrating their flyer outside Paris. The sky seemed filled with airships, and everywhere there were aeronauts and engineers collaborating on bigger and better flying machines. He returned to Russia and enrolled at the Mechanical Engineering College of the Kiev Polytechnical Institute.
He started pestering his parents to send him to Paris, because that was where the Wright brothers were flying. That's where immediately after the Wright brothers' success, the Europeans tweaked their airplanes a little bit so as to pick up a little bit of the know-how that the Wrights had demonstrated, and flying exploded in France.
In 1909, armed with an engineering degree, he returned to Paris. He befriended the elite of aviation there and spent much of his time talking about his vision of an aircraft that could take off vertically, hover, move sideways, and set itself safely back down. The experienced pilots around him laughed at his plans. It was hard enough then getting an airplane to simply fly. Getting it to stand still without falling out of the air seemed laughable. Sikorsky announced to his doubting friends that he would return to Kiev and build a rotary wing aircraft, a helicopter. He bought 2 engines, 15 and 25 horsepower, and boarded a train east.
It's significant to me that his first aircraft and his second aircraft were both helicopters. They didn't fly. We know now that 15 and 25 horsepower is just too little to do it. But these were the first 2 aircraft he attempted. Very wisely, he then decided that he had to, in his words, temporarily postpone the helicopter.
He built a succession of small planes that clearly owe much of their inspiration to the Wright brothers. In only a few years, Sikorsky was one of the leading engineers in Russia. He was put in charge of the aviation subsidiary of the Baltic Railroad Car Works and went to work designing and building aircraft for the Tsar.
He was the first, actually, to come up with the idea of using multiple engines on an airplane. After he had one engine get caught with mosquitoes in the carburetor and the airplane went down, he realized that 2 engines are better than 1.
A multi-engine airplane was a radical idea. Other engineers thought it impossible. If the weight of the engines didn't keep the plane on the ground, they believed the forces and vibration of more than 1 engine would tear the plane apart in the sky.
During his early years, he developed multiple engine aircraft, 4-engine aircraft that were very, very large, which requires a great deal of skill as an engineer to be able to produce a large aircraft that everything works correctly, especially at the time of the type of materials they had to work with. It was quite an achievement.
Sikorsky continued on, however, and the result was a 4-engine behemoth with an almost unfathomable 89-foot wingspan. Called simply the Grand, when it flew in 1913, it made Sikorsky into a Russian hero.
The Grand was a unique experiment in trying to convince the world that a large 4-engine aircraft was possible. He wanted to build this airplane because he wanted to prove that an aircraft had to have 2 characteristics. The Grand was designed to demonstrate 2 critical elements. A, the element of being able to maintain altitude and continue flight if one engine failed on you. And the second, equally important element, that airplane had to be able to lose any one of its engines, inboard, outboard, any one side or the other, and remain controllable. He, with a twinkle in his eye, would talk about the Grand and say that it was a very unique aircraft. It took off at 65 kilometers an hour, it cruised at 65 kilometers an hour, and it stalled at 65 kilometers an hour. But other than that, it was a highly efficient airplane.
His next plane, the Ilya Muromets, was even bigger and became the main bomber of the Russian Imperial Air Force in World War I. Designing aircraft had made Sikorsky wealthy. He was invited to meet several times with the Tsar, and there was talk that he might be knighted for his work.
When the revolution started, that very fact that he had been recognized by the Tsar and had been rewarded by the Tsar made him an enemy of the working class and made him a target of the Soviet, or the Bolshevik at that time, hit squads.
A committed individualist, Sikorsky could not live under communism and decided to leave. His wife chose to stay and refused to let their daughter travel with him. He left penniless and broken-hearted, a refugee bound for Paris, but destined for the United States. After fleeing the Russian Revolution, Igor Sikorsky tried to find work in Paris.
The World War I was still on in 1917, and so he went to France, where the French aviation authorities knew him very well, because that he had purchased during the war a large number of French as well as British engines for his four-engine bombers. They commissioned him to build a large bomber for them.
But when World War I ended, so did the French commitment to aviation. And with no other option, he sailed for the United States.
My father then spent some weeks studying the situation and then decided that he would go to the United States, because he felt that this very, in his words, this very great and wonderful country was probably the only nation which would accept a penniless immigrant with the dream to start building airplanes again.
Though famous in his own country, he was unknown in the United States. He arrived in an unwelcome wave of refugees. There were no opportunities for him in aviation. With World War I ended, no one was building new aircraft. The glut of military surplus biplanes supplied the embryonic commercial aviation business with all the planes it could handle. With nothing else to do, Sikorsky tutored Russian immigrants on New York's Lower East Side. He lectured on math and astronomy and aviation. He lived in poverty, but never let it break his spirit. And as time passed, he built up a following in the large community of Russian refugees. His optimism seemed boundless, and his vision of the amazing future of flight made what were really little more than daydreams seem real.
For a lot of the Russian immigrants, he was something of a hero, something to aspire to, having come here as an immigrant and having all these dreams that he was so anxious to fulfill.
In the early 1920s, Sikorsky resigned himself to the fact that he would never again get to design and build aircraft. Then, in 1923, a group of Russian emigres approached Sikorsky. They had a small amount of money and were willing to work. Would Sikorsky do them the honor of helping them design and build an airplane? Sikorsky set up operations on a chicken farm next to Roosevelt Airport on Long Island. There, he and his small band of Russian immigrants went to work. There was never enough money for payroll and barely enough for materials. No matter, Sikorsky and his Russians worked through night after night on a large twin-engine airplane Sikorsky had designed. And then, with the plane partially built and a desperate need for high-powered engines to make it fly, Sikorsky and his Russians ran out of money. It seemed as if their dream of flight was going to die.
A gentleman drove up, stepped out of his chauffeur-driven limousine, walked around inspecting the airplane, which was being built in the open. The gentleman stopped, started a conversation with Igor Sikorsky, and Igor Sikorsky eventually tells the story that this gentleman sat down and wrote out a check for $5,000, handed it to my father and said, "I believe in you, I trust you, pay me back when you can, go, start building your airplanes." The man's name was Sergei Rachmaninoff, and it was this great pianist and composer who gave Dad his start in America.
The plane Rachmaninoff's contribution made possible was the S-29A, a twin-engine, all-metal transport that was the forerunner of the modern airliner.
It gave him the intellectual freedom and the financial wherewithal to produce the aircraft that a visionary could see, and in the process produce very successful aircraft.
He followed with other designs and started building a reputation as a visionary. In 1930, he gave a newspaper interview in which he described a glimmering future of sleek metal aircraft carrying hundreds of passengers from continent to continent.
Igor Sikorsky predicted in this newspaper interview that New York would be the center and the hub of one of the most busy airline services. Giant all-metal airplanes, sleek all-metal airplanes carrying hundreds of passengers would be taking off every hour on the hour for the far corners of the world.
At a time when most aircraft were still made of fabric stretched over a wooden frame, he talked about pressurized cabins and jet engines as if they were something he had already tested.
To get metaphysical, my father also believed very strongly in intuition, in a sixth sense, which sometimes came to you in a flash in the middle of the night. Sometimes it arrived very, very slowly after you'd been chewing on a problem for a while.
He had his first big hit with the S-38, a flying boat that Pan American Airways used to open new commercial aviation routes to Central and South America. That success brought in other investors, including United Aviation, which was then a major producer of aircraft. And for the first time since leaving Russia, Sikorsky had the money for large-scale design and construction of aircraft. Though still fascinated with helicopters, his business grew because of his success designing fixed-wing aircraft. Among those who visited the Sikorsky factory was Charles Lindbergh, just returned from his flight to Paris. Sikorsky and Lindbergh found in each other kindred spirits. They were both intellectually restless, at the same time cerebral and instinctive. Both had clear visions of aviation as an everyday experience, pioneers who longed to make their field of endeavor commonplace to the point of being boring. Even their differences seemed complementary. Lindbergh looked at aviation from the point of view of a pilot. He wanted to open the world to aviation, and he traveled ceaselessly, charting routes for others to follow. Sikorsky, on the other hand, saw aviation as an engineering problem. To follow the routes Lindbergh was plotting, a passenger plane would have to have a certain range, be able to reach a certain altitude, and carry a certain amount of fuel.
He'd spent a lot of time in the dark listening to music, thinking, and he felt that he could almost see into the future, so to speak. Again, he was a very mystical, very spiritual man, to see what the needs would be, where his ideas could be applied to the betterment of mankind. And I think his particular genius came in his ability to take technology and apply it to the human need.
Lindbergh, Sikorsky believed, was the greatest pilot in the world. Sikorsky, Lindbergh said, was the most gifted aircraft designer he had ever met.
Dad had a great deal of respect for Lindbergh because there's no doubt about it, man knew a great deal about aviation. And in fact, it was this gentle teamwork between Lindbergh and Sikorsky, the mutual respect that they had for each other, that was absolutely wonderful to see in action.
The first plane they collaborated on was the S-40, a flying boat larger and more dependable than any other. Lindbergh was working for Pan American Airways, setting up airmail service to the Caribbean, which was then a sea of islands without landing strips. Tying them together with aircraft posed problems that seemed even to Lindbergh nearly insoluble.
I was growing up at that time. I was a small kid, but I was privileged once in a while to sit in a corner of the dining room when these two giants would discuss the growth of aviation, the need for higher speeds, the inevitability of higher wing loadings, and yet the improvement of our knowledge of aerodynamics, which would still keep landing speeds down while the cruising speeds would go up. Now, it was a wonderful way to grow up because you may have gotten a formal education in high school and in college, but if you were an aviation buff, as I was, those evenings listening to Charles Lindbergh and Igor Sikorsky were the greatest aeronautical academy that anybody could dream of having.
It was the beginning of one of his most productive periods. Working together with Pan Am and Lindbergh, he designed a series of amphibious aircraft that formed the famed Pan Am Clipper fleet. He had in his career played a key role in 2 separate revolutions. In Russia, he had pioneered multi-engine aircraft, which became the first dependable air transports and long-range bombers. In the United States, he had designed the flying boats that had made intercontinental air travel possible. The Pan Am Clippers shrank the world, putting every place in the world within a couple of days' travel of every place else. So, with his company doing well and his reputation secure, he returned to his first love. In the middle 1930s, Igor Sikorsky dug out 30 years of notes and sketches, dusted off a handful of patents, and went to work on the helicopter. Before Igor Sikorsky got seriously into helicopter development, there had been a number of more or less successful experiments in vertical flight. Some could fly but not hover, and others couldn't fly at all. Overcoming the torque of a spinning main rotor and still being able to maneuver was such a big problem that it led many to believe that a practical helicopter would never be developed. Sikorsky, however, believed passionately that the helicopter would work.
He was not interested just in engineering and technology. The primary reason he developed with the helicopter was to rescue people, to save people's lives.
As he worked and reworked the design of his helicopter, Sikorsky said over and over that if a person was in danger, an airplane could fly over and throw flowers to him, but a helicopter could come in and perform a rescue. Working at his Stratford, Connecticut factory, he and his team, still made up largely of Russian immigrants, built the VS-300. Ungainly by modern standards, the 300 was little more than a framework to support the engine and rotor. On September 14th, 1939, Sikorsky sat down in the VS-300's pilot seat for its first flight.
When he climbed into this machine for the first time, he said it was a beautiful chance to relive one's life all over again, to design a new type of flying machine without quite knowing how to design it, build it without quite knowing how to build it, and then you climbed aboard and you opened up the throttle and you tried to teach yourself to fly at the same time that you were the test pilot in charge of the helicopter.
Sikorsky carefully, slowly lifted off, learning to fly the helicopter as it rose. He went only a few feet off the ground, hesitated a few seconds in midair, and settled gently back to Earth. The world had its first working, practical helicopter. While Sikorsky thought the helicopter's future lay in rescue, the first American military man to get a look at the VS-300 instantly recognized its battlefield potential.
People began to realize the idea that we can move large numbers of troops, we can attach weapons to these, and so the United States Army, for example, their aircraft, their helicopters, and these are very, very important for maneuver of the Army units.
In 1942, while looking for aircraft that could be developed to fight German U-boats in the North Atlantic, 2 Coast Guard officers paid Sikorsky a visit. They watched in awe as Sikorsky lifted 25 feet off the ground, lifting a second man below on a suspended rope ladder. In their report on the test, they said Sikorsky's machine had many advantages over the blimps the Navy had developed for anti-submarine warfare. They recommended the Coast Guard buy 3 or 4 for testing, but the Navy balked at the $250,000 price tag. When the officers pointed out that helicopters could serve a search and rescue function, the War Department replied that the Navy was not interested in life-saving. They just wanted to get on with the business of killing the enemy.
I think he was aware that inevitably, sometime sooner or later, it would be used as a military instrument of war. But that he said, was not the fault of the helicopter, because for every single person that it killed, he insisted quite logically that it probably saved 100.
For the remainder of his life, Sikorsky designed and built helicopters. From the R-4, the first mass-produced helicopter, to the UH-60 Black Hawk, the machines he and his company designed and built rewrote the rules of aviation, of warfare, and of search and rescue.
Whenever one talks about Igor Sikorsky today, it is the helicopter that he is remembered as. And that's, I think, justifiably so. It is the last and, in many respects, the most important piece of equipment that my father invented and left for mankind. When I asked him about it, he said that he had a number of favorite aircraft. And obviously the Grand, the first prototype four-engine aircraft, was one. The flying boats were another one. But I believe also he himself felt proudest of his achievements in designing the helicopter.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
The only reason for an airplane to exist is to go fast. At the Great Air Meet in Rheims, Glenn Curtis set a world's record of just over 43 miles an hour, and the quest for speed was on. In 1913, Maurice Prévost was flying a streamlined Dépôt-Dessin monoplane at 126 miles an hour, and Europe claimed the lead in aviation speed. Immediately after World War I, quest for speed became a catalyst for the development of fighter planes. Countries which had not invested in new engines for their wartime fighters would, for reasons of national pride, invest in new engines to race them peacetime. Then, in America in the 1930s, the situation reversed itself. Civilian aircraft, like the Travel Air Mystery Ship and the GB, Waddell Williams racers, became even faster than military aircraft. The reason was simple. Same engines were available to both civil racers and military fighters. The fighters had to carry guns, bombs, oxygen, and radios, while the racers were built only for speed. The world's absolute speed record was passed from country to country. And as the racers became faster and more powerful, they also became more expensive. America's Howard Hughes could afford to build his own racer, and with it set a land plane speed record. But the absolute speed record of 440 miles an hour was set by a Macchi MC-72 seaplane in 1934, financed by the Italian government. Then military aircraft came back into the lead as the Heikel and Messerschmitt firms competed for the title. Messerschmitt Bf-109R set a speed record of 469 miles an hour in 1939, a record that lasted for many years. When the jet aircraft came out, speed records rapidly accelerated, the British breaking 1,000 miles an hour in 1956 in a Fairey Delta II. Speeds continued to climb, finally reaching 2,193 miles an hour in 1976 by the Lockheed SR-71, alias Blackbird. While speed was the object, there were many other benefits in creating ever faster aircraft. Improvement in fuels, streamlining, lubricants, materials, and the list goes on. Speed produced not only prestige and pleasure, but also utility. The speed record setters ultimately paved the way for commercial transports, business jets, and private planes.